Schneid guy.
So now we're going to talk about slow response cardiac action potentials, and I want us to take a look at how this is different from the fast response cardiac action potential. So let's start with the starting point over here. This phase 4, notice that it's not stable. It's drifting and depolarizing, and it's not flat like we saw with the fast response action potential. And the reason for that is we have a combination of some currents. We have an inward sodium current through funny sodium channels, or HCN channels, which are hyperpolarization activated cyclic nucleotide gated channels. And that is going to contribute to this rate of depolarization. We also have some calcium channels involved here, maybe to some minor degree L-type calcium channels, which can be important with pharmacological interventions. Now, these two inward cationic currents are going to exceed any outward potassium current, and we're going to end up with a net depolarization. And as that's drifting up to threshold, I'm going to open up some additional L-type calcium channels here that are going to be responsible for this phase 0 depolarization. Now notice that the rate of depolarization is much less than we saw with the fast response cardiac action potential. And that's again where we get the name slow response. It's based off of that phase 0. The L-type calcium channels remain open, and we end up with again a plateau as we start to get outward potassium current through delayed rectifier potassium channels. Notice that we don't have a phase 1 here. It's not that important. And we see that we have a plateau like we saw with the fast response cardiac action potential. And then once the calcium channels close, I have the unopposed potassium outward current that's going to finish off the repolarization and take me back down. And as the membrane potential repolarizes or hyperpolarizes, that activates these funny channels, or HCN channels again, to start the process all over again. And that is the difference between the slow and fast response action potentials, mainly the phase 4 and the phase 0. Notice that the action potential duration is also prolonged due to this plateau phase, and that also explains why the refractory period in these cells is prolonged compared to neurons and skeletal muscle. And finally, we notice that we have starred here the L-type calcium channels and these funny channels, as they can be targets of pharmacological intervention and also even certain disease states.